Welcome to the deep dive. Today we're really getting into the weeds with C++ plus OA. It's this super powerful language, right? Powers games, operating systems, all sorts of stuff.
It really does. And we're using Professor Jerry Sietsoy's C++ Basics videos, parts 1 and 2, as our guide.
Right. So the mission today is basically to pull out the absolute core ideas, the building blocks you need to, get started.
Exactly. A solid first understanding. Forget the fluff, just the essentials from what Professor Soy covers.
Okay, let's dive in then. Professor Soy kicks things off with the main function. Sounds pretty central.
It is. It's literally the starting line for any C++ program that runs by itself. Computer looks for main and starts executing whatever instructions are inside those curly braces right after it.
So every single program has one, like a standalone one.
Yep, exactly. One main function. It's the entry point.
Okay, and he mentions return 0 right at the very end of main. What's that about?
Ah, right, return 0. Think of that as the program saying, I'm done, and everything went okay. Back to the operating system.
So 0 means success.
Pretty much, yeah. 0 is the standard convention for a successful exit. Non-zero usually flags some kind of error. But for now, 0 means all good.
Got it. Entry point and the all clear signal. Okay, next up. Preprocessor directives and libraries. Sounds a bit technical.
A little, maybe, but the concept's straightforward. A preprocessor directive, like #include, is an instruction for the compiler before it actually compiles your main code.
Before, okay.
Yeah, think of it like a prep step. #include specifically tells the compiler to go grab the contents of another library and sort of, well, paste it into your code.
And the example was #include IOStream. So IOStream is one of these libraries.
It is. A really important one. Libraries are basically toolkits full of pre-written code functions that do a common jobs.
So you don't have to reinvent the wheel every time.
Exactly. IOStream specifically gives you tools for input and output, getting stuff onto the screen, reading stuff from the keyboard.
Okay, so it lets the program talk to me, the user.
Precisely. It provides the count tool, which Professor Tsoi introduces. That's how you display things.
Right, count. And it uses those double arrow things pointing left.
Yeah, the operator. The technical name is stream insertion operator, but just think of it as pointing the data towards count to be displayed.
Like in the Welcome to Hogwarts example. Count, welcome to Hogwarts. Makes sense.
Exactly. And then there was that endl at the end.
Yeah.
Endl.
Oh yeah, what does endl do again?
It inserts a new line. So after printing Welcome to Hogwarts, the cursor moves to the beginning of the next line. Anything you print after that starts fresh on a new line.
Keeps the output tidy.
Yep. And he also mentions system pause.
Ah, right. For beginners, he said.
Yeah, on some systems, especially older Windows setups using certain compilers, the output window might flash open and then immediately close when the program finishes.
Huh?
System pause just holds it open so you can actually, read the output.
Okay, a little helper tool for learning so you don't miss your Hogwarts message. Cool. All right. Moving on to the actual stuff programs work with data types.
Right. Professor Soy talks about simple, structured, and pointer types. We're focusing on the simple ones for now, the absolute basics.
Okay.
Well, first, you've got integral types. These are for whole numbers. No fractions, no decimals, just, 1, 2, 3, and 5, 0. Things you count.
Got it. Integers, then floating point types.
Sure.
For the decimals, I guess.
Exactly. Numbers that can have a fractional part, like 3.14159 or nectifus 0.5.
And he mentioned two kinds, float and double.
He did. The main difference is precision, basically, how many decimal places they can accurately store. Float handles about 6 or 7.
Okay.
Double handles around 15, much more precise.
So why ever use float?
Well, float uses slightly less memory in some situations, like on really resource-constrained devices or maybe some specific graphics stuff that might matter. But Professor Soy recommends sticking with double when you're learning.
Why is that?
Just because the extra precision helps avoid weird, subtle errors that can pop up with float if you're not careful. For general programming, especially starting out, double is usually safer and easier.
Okay, double it is for now, more accurate. He also briefly mentioned enumeration types.
Yeah, enum. Those are ways you can define your own custom data types, basically. A bit more advanced, so we'll just park that idea for now.
Fair enough. So we know about types of data. How do we actually, hold on to data and name it in the code? Variables and constants.
Exactly. Variables are the workhorses. Think of them as labeled boxes or containers. In the computer's memory, it's RAM. Each box is designed to hold a specific type of data.
Like an int box or a double box.
Precisely. And the key thing about a variable is that the value inside the box can change while the program is running.
How do you make one?
You declare it. You state its data type, then give it a name and identifier, like int student age or double assignment mark.
And then you put something in the box.
Right, using the assignment operator. That's the single equals sign. So student age is 21.
And Professor Soy stressed this. Here isn't like mathematical equality.
Absolutely crucial point. It means take the value on the right and store it into the variable on the left. It's an action, an assignment, not a statement of fact like in math.
Got it. Store, don't equate. What about constants then?
Constants are similar name storage, specific data type, but with one huge difference. Once you give a constant its initial value, that value is fixed. It cannot be changed later in the program.
Useful for things that shouldn't change, like pi maybe.
Exactly. Or maybe a tax rate that's fixed for the program's logic. And the rule is you must give a constant its value when you declare it. You can't declare a constant and assign it later.
Okay, initialize immediately. So variables change, constants don't.
Yeah.
Got it. Now, what happens when we mix these variables and constants with operators like plus or minus expressions?
Yep, expressions. An expression is just some combination of values, could be variables, constants, literal numbers and operators, maybe even function calls. That boils down to a single resulting value.
Like student age plus 1.
Perfect example. That expression results in a value. Professor Soy mentioned integral expressions where everything involved is an integer.
Okay.
And floating point expressions where everything's a float or a double.
And mixed expressions, where you combine them.
Right. Say you multiply an int by a double. What happens? C++ usually performs an implicit conversion.
Implicit, like automatic.
Yeah. It'll typically upgrade the integer to a double temporarily for the calculation, so the result is also a double. It tries not to lose precision.
Okay, that makes sense. But sometimes you want to force a conversion. You talk about typecasting.
Exactly. Explicit conversion or typecasting. Sometimes the automatic conversion isn't what you want, or you need to be really clear. Maybe you want to chop off the decimal part of a double.
Ah, okay.
Professor Soy showed static cast int some double value. That static cast is the modern C++ way to say, hey, compiler, treat this some double value as an integer right here.
And it just drops the decimal part, like 3.9 becomes 3.
Usually, yes. Truncates. Doesn't round, just chops it off.
Okay, useful if you specifically need just the whole number part. All right, let's get into the operators themselves, plus minus.
Right, the arithmetic operators. You've got plus, addition, subtraction, multiplication, division, and the modulus operator, percent.
Modulus, what's that one?
Press a percent gives you the remainder of a division. So 10% 3 would give you 1 because 10 divided by 3 is 3 with a remainder of 1.
Okay, remainder, got it. Now, the order matters, right? Precedence.
Hugely important. Just like in math class, C++ has rules. Multiplication, division, and modulus percent have higher precedence. They get done before addition plus and subtraction.
So 2 plus 3, 4 is not 20, it's 14, because 3, 4 happens first.
Exactly. 3 times 4 is 12, then add 2 gives 14. And if you have operators of the same precedence, like 10, 2, 3, they're usually evaluated left to right. So 10 divided by 2 is 5, then 5 times 3 is 15.
Okay, Pem, dares, or Bodmes all over again. What if I want the addition to happen first in 2 plus 3, 4?
Parentheses. Use. Anything inside parentheses gets evaluated first, overriding the normal precedence rules. So 2 plus 3, 4 would calculate 2 plus 3 to get 5, then multiply by 4 to get 20.
Right. Parentheses rule.
Gotcha.
He also mentioned compound operators, like plus.
Yeah, shorthand. Y plus 1 is just a shorter way to write y plus 1. The same for verse, y plus 1. They combine the operation and the assignment.
Useful, maybe.
They can make code shorter, yeah. But Professor Soy suggested, and it's good advice for beginners, maybe stick to the longer form, y plus 1 at first, just because it's clearer what's happening until you get comfortable.
Keep it simple. Makes sense. Then there were plus plus and 1. Increment and decrement.
Even shorter shortcuts, specifically for adding 1 or subtracting 1. So x plus plus adds 1 to x, and x subtracts 1.
Okay, but there was a catch. Pre versus post increment.
Yes. Subtle but important. Plus x, pre-increment means increment x first, then use its new value. X plus plus, post-increment, means use x's current value first, then increment it.
Okay. When does that actually matter?
It matters most when you use it inside a larger expression, like y equals plus x versus y equals x plus plus. In the first case, x increases, then y gets the new value. In the second, y gets the old value of x, and then x increases.
Ah, okay. That could definitely change results. But if it's just on its own line, like Harry plus plus 1 from the example.
Then pre and post usually don't make a practical difference. Harry plus plus 1 just means the same as Harry plus 1 or Harry plus 1.
Got it. Okay. Shifting gears slightly. Text. How do we handle words and sentences? The string type.
Exactly. For working with sequences of characters like hello world or abracadabra, C++ gives us the string data type, but it's not built in quite like int or double.
What do you mean?
You need to explicitly tell the compiler you want to use strings by including its header file. Remember, hashtag include. For strings, you need hashtag include string at the top of your code.
Okay, include the string toolkit. Then what?
Then you can declare string variables, string message, and you assign text to them using double quotes, message welcome.
Double quotes. Important. And he mentioned length and position.
Right. Every string has a length, the number of characters it holds, including spaces, and the characters inside are indexed starting from 0.
0, not 1.
0, super common in programming. So in the string cat, C is at position 0, A is at position 1, and T is at position 2. The length is 3, but the last position is 2. Takes a little getting used to.
0-based indexing. Okay, gotta remember that. So, we can output stuff with count. How do we get input from the user?
Exactly. Sinian's the counterpart to count. It also comes from that IOStream library. It reads data from the standard input, which is usually the keyboard.
And it uses the opposite arrows.
Yep, the stream extraction operator F. Think of it as pulling data out of the input stream and putting it into your variable. So scene usage waits for the user to type an age and press enter, then stores that number in the userage variable.
Okay, what if I need to read, like, 2 numbers?
You can chain them. Sin num1, num2. But the crucial thing Professor Toy highlighted is how the user types them in. The user needs to separate the values with white space, usually just a space. So they type, say, 10, then a space, then 25, then enter. Sin uses that space to know where the first number ends and the second begins.
Ah, the space is the separator. Good to know. Okay, this feels like a lot of pieces. The Professor Snape example he used sounds like it ties things together.
It really does. It's a great little scenario. You have Hermione and Harry, both given the same starting numbers and operators, but they get different results.
Why was that again?
Operator precedence. It all came down to where the multiplication was placed, because sanity has higher precedence than... Plus, the order of calculations changed, leading to Hermione getting 26 and Harry getting 14 initially.
Wow, okay. Just moving the 10 changed the outcome that much.
Exactly. It's a perfect, simple illustration of why precedence matters so much.
And then Harry got a little help.
Yeah. The program then used sin-beat harmony to ask the user for a number.
Right, getting input.
That number was stored in beat harmony, and then it was added to Harry's score using Harry ++2, so that showed input, and the post-increment operator in action.
And there was a string in there, too.
Yep. A string variable magical statement was created and assigned abracadabra, and then that string was printed to the screen using count.
So it really pulled together variables, operators, precedence, input, output, and strings. Neat.
It's a very effective example for showing how these fundamental parts interact in a real, albeit simple, program.
Okay, let's try to wrap our heads around what we've covered in this deep dive. Feels like quite a bit of foundational ground.
Definitely. We started with the absolute core, the main function, the entry point, and return 0 for saying all good.
Then the whole idea of hashtag include to bring in toolkits like IOStream for the basic communication input and output.
Yep. Using count to send stuff out to the screen, endl for new lines, and that system pause trick for beginners.
We hit the basic data types int for whole numbers. Double is the go-to for decimals when learning. Briefly touched on float and enum.
Then variables, those change containers, and constants, the fixed ones, remembering that crucial difference between assignment and mathematical equality.
Right, and how constants must be initialized right away. Then expressions, mixing variables and constants with operators.
And how C++ handles mixed types with implicit conversion, usually aiming for more precision, plus static has for when you want to force a type change, like making a double an int.
Then the operator rules precedence, AEN% before plus A, and using parentheses to control the order. Super important, as the Snape example showed.
Definitely. We also saw the shorthand compound operators like plus and the increment-decrement operators ++n, remembering that pre versus post nuance.
And working with text using the string type, needing hashtag include string, using double quotes, and remembering that 0-based indexing.
Followed by getting user input with sin-a and the importance of using spaces to separate multiple inputs.
And yeah, that Snape example really crystallized how precedence, input, and variables all play together to get a final result.
It's a solid foundation. You now kind of get the structure of a basic C++ program, how it handles different kinds of data, does calculations, and talks to the user.
That Hermione and Harry difference was a real eye-opener. Such a small change, such a different result.
It really highlights that attention to detail is key in programming. Those rules, like precedence, aren't just suggestions.
So for anyone listening who's thinking, okay, I get these basics, what next? Where do they go?
We'll keep going. Professor Soy probably has more videos. Or look for other beginner C++ tutorials or books. The most important thing now is to actually try writing code.
Like little practice programs.
Exactly. Take these concepts, variables, sin, count, basic math, and try to make something tiny. A simple calculator. Maybe something that asks for a name and says hello. Play around, experiment. That's how it really sinks in.
It's amazing to think, though, that the complex software we use every day is built up from these same fundamental ideas,
Yeah.
just layered and combined in more intricate ways.
Absolutely. Data, operations, input, output. It's all there.
So here's a thought to leave you with. Now that you grasp these basic C++ building blocks, what simple problem, maybe something you encounter daily, could you start to imagine solving or automating just by piecing these fundamentals together? Something to ponder. Thanks for joining us on this deep dive.